Okay, so that is about that. So let's go to this tool that we have here, this fantastic tool. So we usually start transactions from, you know, collecting, adding transactions to the ledger from the transactions you and I performs on the blockchain. So I want to send anything. Maybe the message I want to send to you is just hi or hello. It's a message, and of course you can read this message as long as the message gets across to you, and you can read the information of the blockchain instantly. The good thing about it is the data that you are pushing onto the network is, we need to ensure that this data is not modified by anybody. If you look at it closely, I have a copy of the information, you have the copy of the data, another person is also having the copy of the data somewhere. You must have a way to ensure that whatever data you are pushing onto the network would not be modified in any way. And the way they ensure that is by using something we call the hashing algorithm. The hashing algorithm takes any variable length characters and, turn this variable length character to a fixed length. And if you modify it, for instance, now there is nothing inside this box right now, it's just an empty space. And if I change the value, okay, let's say that is my data, I want to just simply say hello. You can see that as I'm changing the value here, notice, take note of this part, you see the hash also changing. See the hash also change. If I put my name, Abidin is Abidin, and if I want to put hi, hi is hi. As long as you are using this SHA-256, which is one of the algorithms to hash data, um, hashing data, please take note, is a one-way thing. Okay? Once you hash the data, you can't get the plain text information from the hash itself. What I mean by that is, in encryption and decryption, I can encrypt and also decrypt. If I have the key, like the private key that I mentioned earlier, to sign your transaction, you are encrypting at a point and you're also decrypting for you to be able to access your files. So when you are encrypt, you need the key, either the same key or a different key, to basically um, decrypt that specific content. Um, but in Because in encryption, of course, we have two types. We have the symmetric encryption and the asymmetric encryption. The symmetric encryption uses the same key. For instance, I want to encrypt Abide now as a name. If I use Olamide as the key, and I want to send this encrypted content to a friend in Lagos, for that, my friend in Lagos to be able to access the content, decrypt the content, requires that key. So which is that Olamide as a key, it requires it for him to be able to decrypt the content. Otherwise, he will not be able to do that. So the encryption is only ensuring the confidentiality, that this information that I'm sending across to someone can only be accessible by that intended recipient. So anything absolutely after that, there is no privacy in such information. So that is if you are using symmetric encryption. Asymmetric encryption uses both private and public that we are going to look at as we proceed. So, and that is what we use on the blockchain technology. We use the private and the public. And why do we use the private and public key? Because I want us to see it from that angle rather than just discussing the private key and public key. I want us to see, why do we need the private key and the public key. So when we get there, we'll discuss more on that. But at the baseline is to ensure that whatever data you are sending across, you create a hash of that data. So if someone is able to access your data and modify this data. The next thing, let's say instead of I, you put I dot. It changes the hash will definitely change. And once the hash, the blockchain network, discover that this information is not as the same as the original, then it will break the entire thing. And we'll see that as we proceed now. It will break the entire thing, and we can, at least through this um, application here, I think we should be able to wrap our heads around this content. So hash is the first thing. So whatever information you are sending across the network, you need that hash. Okay. I want to send 1 Bitcoin to my friend in Lagos. Okay, 1 Bitcoin to my friend. That data that I'm sending will be hashed. Hash of that data will be calculated. So that someone will not see the transaction because everybody that is participating on the network has the copy of the transaction. Someone will not just go ahead and change the value, or even the sender. There's so called this concept of double spending. I can spend 1 Bitcoin and try to respend this 1 Bitcoin again. So, but immediately you push this data to the network ensures that you can no longer modify the information. Because if you modify the information, there are several things that you have to do. There are several calculations, other calculations that you have to do for you to be able to efficiently modify and make changes across the network. And we'll see that. So the first thing, you hash whatever content that you want to do. And so this becomes more like a transaction now. So I'm sending I to my friend in Lagos. Mr. A is sending 1 Bitcoin to his friend somewhere in the US. These are transactions. So we collect all this list of transactions. Who are the people collecting this list of transactions? So we usually call them miners, and we get there. So when we get there, we discuss who are the miners and their purpose. So what we do is that we take these transactions, transaction one, transaction two, transaction three, transaction four. That's our ledger. We put everything together in a block. Okay, in a block. So is more or less I have some um, pages inside a notebook, for instance. So each page inside a notebook will be regarded as a data, and the entire notebook itself could be regarded as a block. So you take all this list of transactions, put them together, and put all these transactions in a block. So it's more or less like moving everything, transaction one, transaction two, put everything together and create another document and put all these transactions inside that document. So that is what we usually refer to as a block. So the first thing is the transaction itself. The second thing is to collect all these transactions, either one transaction, two transaction, multiple transaction, or even no transaction at times. Okay, no transaction at time. You collect them together and you create a block. So what we mean by that block now, we contain what? List of transactions. So every block will contain list of transactions. So, but before we can accept that these transactions are valid, okay, the transactions are valid, that transaction has to be mined. And this is where we have some people they call miners. Okay, we have these people they call miners. Their job, so when you send transaction on a blockchain network, either you are sending money or you are simply sending hi to someone, as long as you are using the blockchain network, immediately you send that transaction, it goes into a pool. Yes, we call it mempool anyway. I don't want to go into some of these technical part. More reason why I said is much more than we might actually